Assalamualaikum. My name is Natasha, and I will be presenting the introduction, business rules, and ERD diagram of our library management system. First, let me explain what the library management system is. The library management system, or LMS, is a database-driven system designed to manage daily library operations in a more efficient and organized way. The system handles important activities such as member registration, book borrowing, and book reservations, and fine tracking. Next, I will explain the business rules that were used to design the database. The first rule is that members must register before accessing any library services. Second, each book must belong to only one category. Third, members are allowed to borrow a maximum of 5 books at a time to ensure fair access to library resources. Fourth, every borrowed book follows a standard loan period of 14 days. Fifth, late returns will be charged a fine of RM 0.50 per day overdue. Sixth, the members may reserve books that are currently unavailable, and multiple reservations can be made for the same book. Finally, staff members are responsible for processing registrations, loans, and reservations within the system. Based on these business rules, we developed the Entity Relationship Diagram, or ERD. The ERD consists of 7 entities: staff, category, member, book, loan, fine, and reservation. These entities are connected through relationships that reflect how real library operates. Primary keys and foreign keys are used to establish relationships between tables and ensure data integrity. The ERD was designed using Draw.io and follows crow's foot notation to clearly show the relationship between entities. That concludes my presentation. Thank you.
So my name is Nur Azara, and I'll be presenting data dictionary and data schema. So the first part, the data dictionary serves as a reference guide for the library management system database. It documents every attribute in each table, including its data type, description, and constraints. This ensures all team members and developers understand the structure and rules of the database clearly. So next, the database schema was designed and normalized to third normal form 3NF to eliminate data redundancy and ensure data integrity. The schema consists of seven tables, where each table represents a core entity of the system. Primary keys are denoted by an underline, and foreign keys are indicated with an asterisk. So 3NF removes transitive dependencies, meaning every non-key attribute depends only on the primary key and nothing else. This keeps the data clean and consistent.
My name is Nur Izzati Nazira. Now I will explain task 5, which is creating database tables using RDBMS. For this, we will focus on the loan table as it is the most complex table in our system. The loan table is created using the create table statement in MySQL. It consists of 7 attributes, which are loan ID, loan date, expected return date, actual return date, member ID, book ID, and staff ID. To enforce entity integrity, we set loan ID as the primary key with null constraint. This ensures that every loan record is uniquely identifiable and no duplicate loan records can exist in database. To enforce referential integrity, we apply 3 foreign key constraints. First, member ID reference as the member table to ensure that every loan must link to a valid registered member. Second, book ID reference the book table to ensure that only existing book can be borrowed. Third, staff ID reference the staff table to ensure that every loan transaction is processed by a valid staff member. All 3 foreign keys are set with on-update cascade and on-delete restrict rules. On-update cascade means that if a reference ID is updated, the change will automatically reflect in the loan table. On-delete restrict means that a parent record cannot be deleted if it still has related loan record, which protects the integrity of our data.
Hi, I'm Nafisa Mira. For this project, I was responsible for task 6 and task 7, which covers inserting records into the database and creating the queries. Starting with task 6, which is insert records. After all 7 tables were created, the next step was to populate them with data. I wrote insert statements for all 7 tables, making sure the data was realistic and reflected how an actual library would operate day to day. As you can see, in the record summary table on this slide, the tables are divided into 2 types: parent tables and transaction tables. The parent tables are staff, category, member, and book. These hold the core static information of the system. Staff has 6 records, category has 6, member has 10, and book has 12 records. These records don't change as frequently. They represent the people and resources that the library manage. The transaction tables, on the other hand, are loan, fine, and reservation. These are the tables that capture ongoing library activity. Loan has 20 records, while fine and reservation each have 50 records. All of these transaction records span a 3-month period from March to June 2026 to simulate real borrowing activity over time. The reason transaction tables have significantly more records than parent table is because in real-world library environment, multiple loans, fines, and reservations are being created on a daily basis. So having more transaction records make the data more meaningful and useful for analysis and decision making, which ties directly into queries we create in task 7. Hi, I'm Nafisa Mira. For this project, I was responsible for task 6 and task 7, which covers inserting records into the database and fitting the queries. Starting with task 6, which is insert records. After all 7 tables were created, the next step was to populate them with data. I wrote insert statements for all 7 tables, making sure the data was realistic and reflected how an actual library would operate day to day. As you can see, in the record summary table on this slide, the tables are divided into 2 types, parent tables and transaction tables. The parent tables are staff, category, member and book. These hold the core static information of the system. Staff has 6 records, category has 6, member has 10 and book has 12 records. These records don't change as frequently. They represent the people and resources that the library manage. The transaction tables, on the other hand, are loan, fine and reservation. These are the tables that capture ongoing library activity. Loan has 20 records, while fine and reservation each have 50 records. All of these transaction records span a 3-month period from March to June 2026 to simulate real borrowing activity over time. The reason transaction tables have significantly more records than parent table is because in real-world library environment, multiple loans, fines and reservations are being created on a daily basis. So having more transaction records make the data more meaningful and useful for analysis and decision making, which ties directly into queries we create in task 7.
Next, I will explain query 3, which focuses on analyzing book categories in our library system. The purpose of this query is to analyze which book categories are borrowed most frequently, including the number of unique members who borrow from each category and the average loan period. For this query, we are using 3 tables, which are category, book, and loan. The aggregate function used are count and AVG. Looking at the SQL statement, we are selecting the category ID, category name, and shelf location from the category table. We then use count on the loan ID to get the total number of borrowed books, count distinct on the member ID to get the number of unique members who borrow from each category, and AVG with that diff to calculate the average loan period in days. The 3 tables are joined using join, where category is joined to book based on category ID and book is joined to loan based on book ID. The results are then grouped by category and ordered by total borrowed books in descending order. Based on the query result, technology and science are the top 2 most borrowed categories with 5 loans each. This result assists library management in identifying high demand categories and making informed decisions on expanding the library collections.
Now, I will proceed with the live demonstration of our library management system database. My name is Nur Izzati Nazira. I will be using PHP MyAdmin to show the database that we have created. Here you can see our database named Library Management System. It consists of 7 tables, which are staff, category, member, book, loan, fine, and reservations. All tables have been successfully created and populated with sample data. If we click on the loan table, you can see that we have insert 20 transaction records spanning from March to June 26. Each record contains the loan ID, loan date, expected return date, actual return date, member ID, book ID, and staff ID. Some records show null in the actual return date column, which means those books have not been written yet. Next, in the fine table, we have 15 records. You can see the fine amount and fine status for each loan. Some fines are marked as paid, while others are still unpaid. The fine is calculated at 0.50 cents per day overdue based on our business rule. In the reservation tables, we also have 50 records showing members who have placed reservations on books that were unavailable at the time. Each reservation is linked to a member, a book, and a staff member who process it. Now we will demonstrate our query. This query tool which retrieves a summary of members who have unpaid fines. We are using aggregate function count, sum, and max across 3 tables, which are member, loan, and fine. So I will run the query. As you can see from the result, MEM006 Khairul Anwar bin Ismail has the highest total unpaid fine of 90 ringgit with 2 unpaid fine records. This query is very useful for library staff to identify which members need to be followed up for fine payments. Next is query 3, which analyzes the most borrowed book categories. We are joining 3 tables, which are category, book, and loan, using count and AVG aggregate functions. I will run the query. The result shows that technology and science are the top 2 most borrowed categories with 5 loans each. These information help library management to make better decisions on expanding the collection in high-demand categories. The average loan period across all categories is 14 days, which is consistent with our business rule. That concludes our demonstrations. Our library management system database is fully functional with proper tables, relationships, constraints, and meaningful queries that support real-world library operations. Thank you.